All right, we're going to do a lesson today on compound inequalities, and we're going to look at the OR type problems. So before we begin, I'd like for you to think about what it means when I say OR. If I say, I would like an Xbox or a PlayStation, if that's my Christmas wish list, am I expecting to get both the Xbox and the PlayStation, or am I just expecting to get one or the other? If I say or, then I'm expecting to get one or the other. We've looked at and problems the last few days, and today we're going to look at or. Think about the difference here. If I say I want an Xbox and a PlayStation, I'm a spoiled brat, and I'm hoping to get both of them. But if I say I want an Xbox or a PlayStation, I'm expecting to get only one of them. Only one thing will be under the tree, one or the other. So it's the same thing with inequalities. When we're looking at the and problems, we're looking for things that happen at the same time. We're looking for the overlap. We want the values of x that are greater than 0 and that are less than 1. So it's all those values in between 0 and 1. But if I say that I'm looking for values that are less than 0, that's values less than 0. So that's -1, -2, all of those numbers that are less than 0, or numbers that are greater than 3. That means I could also have this whole other set of solutions. I could have 3, 3.5, 3.7, 3.49268, whatever. You get the idea. I want this one or I want this one. So we have a whole lot more options. With and problems, we're looking for the numbers that happen at the same time. It has to be greater than 0 and less than 1. So that's a very finite amount of numbers there in between 0 and 1. But if I'm talking about I want the x's less than 0, that's a whole big bunch of numbers, infinitely many. Or x is greater than 3, that's a whole nother infinitely many set of numbers. So I can have all of those solutions over there or all of the ones on the other end of things. So let's start graphing these and kind of look at what that means. So first, what I want to do, just like it's an equation, I'm going to draw my dotted line through here. I want to move the 3 over. So how do I get rid of a positive 3? Why subtract 3? We know if we subtract it from one side, we have to do that to the other. So 7 minus 3. Okay, so 3 take away 3 is gone. I have 2x, and I still have 7 take away 3 over here, which is 4, and I want to keep my sign. I'm going to divide both sides by 2, because 2 divided by 2 is 1. 1 times x is x. 4 divided by 2 is 2. So we're looking for values of x greater than 2. Okay, before I graph that on the number line, I want to come over here and do this other inequality. I have 2 inequalities I have to solve. We're saying we want the x is greater than 2 or whatever this solution is. So minus 3 from both sides. I did this 2 different ways just to kind of show both methods, vertical or horizontal. 1 take away 3 is -2. Divide both sides by 2. And x is less than -1. So I want values of x greater than 2 or values of x less than -1. So let's put that on the number line. -1, 0, 1, 2, 3. We don't have to put them all in there. So x is greater than 2. We're not equal to 2, so we want an open circle. We're looking for the values greater than 2. Or we're looking for the values of x not equal to, but less than -1. So we're showing, we're not including the -1, but starting at -1, so I get all of those decimal numbers in between, and less than. So everything down here is a solution. Everything up here is a solution. All of those numbers. The only thing that isn't a solution is what's in between these. So my solution would go from -infinity up to -1, or it could be from 2 up to positive infinity. This is one way of writing it. This is called, let me think here, interval notation. Or we could just leave it like this. We could just say x is greater than 2 or x is less than -1. All right, let's try another example. Again, continue to think about what the word or means. We want all of this or all of this. So again, subtract 3 from both sides. -2x is greater than, if I subtract 3 from here, that's 0. Subtract 3 from here, that's 4. Divide by -2. I call this the golden rule of inequalities. The golden rule says if I divide or multiply both sides by a negative, I have to flip my symbol. So -2 divided by -2 is a +1. 1 times x is x. -2. Let's do this one over here. Subtract 2 from both sides, so negative 4x. 2 take away 2 is 0. Negative 2 take away 2 is negative 4. Again, I'm dividing both sides by a negative 4. Negative 4 over negative 4 is 1. 1 times x is x. Negative 4 over negative 4 is 1. I have to put that one because I don't have an x there as a placeholder. And I've got to flip this symbol. The golden rule kicks in. I divided both sides by a negative. Okay, so let's put these numbers on the number line. Negative 2, negative 1, 0, 1, 2. Okay, so we're looking for all the values of x greater than 1 or all the values of x less than negative 2. And there they are. So it's everything down here up to negative 2 or everything starting at 1 but not including and going up. Okay, let's try another example. And I should keep the word or, by the way, in between here so that we know it's an or problem. Because let's think about real quick, if it was an and problem, what would that mean? If we were saying x is less than negative 2 and greater than 1, there is no number that fits both of those criteria. There's no number that's being overlapped. So that would be no solution if this was an and problem. So if it was an and, it would be no solution, because there is no overlap. But since it's an or problem, we're saying all of these numbers down here are solutions or all of these numbers up here are solutions. All right, let's try one more. So we're going to divide both sides by a negative 8. So I have x is less than, golden rule, negative 1. Subtract 2, that'd be negative 4. Negative 4x is greater than negative 4. Divide. Flip it. Oh, would this be a negative 1? Nope, that's a positive 1. Caught my own mistake just in time. Okay, so I'm going to graph it. 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. So we want x is less than 1 or x is greater than, nope, let's see here. Divided both sides, so I flipped it. Or x is less than or equal to 1. There we go. All right, so when I do this, I have this overlap here, and they're pointing in the same direction. So even though it's an or problem, and I have these solutions, and when I look at it, it looks like there's two different graphs, but really, this one inequality right here takes care of all of it. So the only thing that I need to write is my x is less than or equal to 1, because this takes care of all the x's less than 1. We have to use this one because we're also including the x that is equal to 1. So this would be my final solution, x less than or equal to 1. So in summary, let's look at this. How do we do this? If it's an or problem, we have to solve each inequality separately. So I solved this one, then I solved this one. We solve them separately. And then remember, in solving, if we divide by a negative number, you have to flip the sign. I want you to think about why that is real quick, just a real quick tutorial here. If I have x and 3, or 1 and 3, which one is greater? Well, obviously the 3 is the bigger one, right? We have the mouth open towards the bigger one. So 1 is less than 3 is how we would read this. 1 is less than 3. If I divide both sides by a negative 1, this changes and I have negative 1 and negative 3. So think about that. What would be the true statement now? Which one is the bigger number? This one is bigger. Think about owing people money. I'd rather owe someone only $1 than I would owe them 3. This is being a bigger number. This is more in the whole. So negative 1 is greater than negative 3. We'll see that when we divided both sides by a negative, we had to flip the sign to make it a true statement. All right, so then when we do it, we plot it on the number line. Remember, if it's less than or equal to or greater than or equal to, we use a closed circle. If it's just less than or greater than, we use an open circle. And then think about the solution as you analyze the number line and write your final solution. So like in this case, this one inequality took care of both of them. So this would be my only answer that I would have to write. But on this one, I would have to write both inequalities because we're saying all of these are solutions or all of these are solutions. Same thing here. Take into consideration both inequalities because everything down here is a solution or everything over here. So I hope that clears things up and helps you understand OR problems. If you have any questions, feel free to shoot me an email.